Dear Professor, I would like to submit my homework to sharp number 3 about control 3 stable and RC0 models by discipline on GUI at Visual Studio Software. Use C++ and C# language. In this talk, I use this. use the Arduino create a C# language and use the Visual Studio create a C++ language, create the language program, and create this control board in Visual Studio like this. To control three stable motors or three like the serial motors. Control case input 1, 2, 3, 4, 5, 6, or press the star 1, stop 1, start 2, stop 2, start 3, stop 3, and control the motor 1, motor 2, motor 3 turn different turn. Okay. First, I will introduce the micro serial motor. For the name is SG19. Like this, the serial motor have 3 pins. One is brown, and one is red. No, sorry. One is orange, one is red, and one is brown. The orange pin is a single pin. Connect the single pins on Arduino. And the red pin is the power pin. We can connect the 5 volts pin on the Arduino. And the brown pin is the ground pin. Connect the ground pins, 3 pins of Arduino. The SG19 micro serial is a small and lightweight serial motor widely used in hobby electronics, robotics, and Arduino projects that operates using pulse-width modulation signals to control its position. It can rotate approximately 118 degrees and is known for its action and ease of use. If you use just one serial, you can directly from the Arduino 5 volts pin, not directly from the Arduino 5 volts pin if use multiply serials. For the stable motor, stable motors convert electricity into rotation. Not only those are stable motor convert electrical power into rotation, but it can be very accurately controlled in terms of how far it will rotate and how fast. Stable motors are so named because each pulse of electricity turns the motor one step. A A step motor is a brushless electrical mechanical device that covers a series of electric pulses applied to its excitation windings into precisely defined step-by-step mechanical shaft rotations. The motor's shaft rotates through a fixed angle for each discrete pulse, with this rotation being either linear or agonal. A single pulse into input results in a one-step movement. Like, like this is the outside of the stepper motor. Like all electric motors, it has stator and rotor. The rotor is the movable part which has no windings, brushes, and a commutator. Usually, the rotors are either variable reluctance or permanent magnetic. The stator is often constructed with multiple and multi-phase windings, usually of three or phase four phase windings wound for a required number of poles decided by desired angular displacement per input path. Unlike other motors, it operates on a programmed discrete control powerness that are applied to the stator windings via an electronic driver. The rotation occurs due to the magnetic interaction between poles of sequence se- the poles of sequentially ener- energized stator winding and the poles of the rotor. The first program is control the serial motor. RC serial motor use the Arduino created the Arduino code. In the first include the serial core and define the ground root is 9600 and serial the survey is correct the base 1, 2, 3. Its mean is the serial motor 1, motor 2, motor 3. The name is serial base. And the base cut is 0. For the mean that the serial 1, serial motor 1, motor 2, motor 3 is the internal angle is 0. That if they are not work or finished the work, the angle is 0. And we can set this, we can set the base 1, base 2, base 3. It means the motor 1, motor 3, motor 2, motor 3 each collect the 12, the 11, 12, and the 13, and I don't know. And these motors, right, the begin angle is 0. In the void loop, we can set serial rate from the ground road. If if we input one like this, one input like one into the serial port of Arduino, the motor 1 from 0 delay 1 second and to the 19 degree and delay 1 second and to the 180 degree and break stop. Case 2, the motor 1 from the 180 degree to the 90 degree and to the 0 degree, and each step delay 1 second and stop. The case 3, input 3 into the serial port of the Arduino, and 3, 4 is for the motor 2. The 5 and 6 is for the motor 3. And 3 and 5 is 1, 0 to 19 to 180 degree of the motor 2, motor 3 turn back. And 4 and 6, case 4 and case 6 is the function, is the action of motor 2 and motor 3 from 180 to the 90 to the 0. Okay, this the serial motor. And for the stable motor, encode stable core and run bound rate 9600 and define the stable motor is 2048 steps. The stable number is 28BYG48, and in the motor state is stop and clockwise and counterclockwise, and motor state 1, motor 2, motor 3 are stop. Define the step motors. The motor 1 steps connect 10, 11, 12, 30. The motor is 6, 7, 8, 9, and the motor 3 is 2, 3, 4, and 5 pins on the Arduino. In the word step, serial begin, bound root, and the motor 1, 2, 3, the speed are 8. And in the word stable motor, stable rate if the state is clockwise, motor step 512 steps. Either is minus 512 steps. The 512 it means the motto is clockwise, and the minus 512 steps, it means the motto is counterclockwise. And in the word loop, a set with several variables if it's more than 0, and read from the zero point of Arduino. If the case switch the value from the command. If case 1 is put 1 input into the 0 point, the motor 1 states stop, and the motor 2 state and the motor 3 state are stop. The motor 1 state is clockwise from here, clockwise from here, and the motor step is 512. The motor clockwise, and print the motor 1 clockwise and stop. And the case 2, the motor 2 and motor 3 states are stop, and the motor state is counterclockwise for here. The motor one step is minus 512. The motor is counterclockwise, and print motor 1 counterclock and stop. For the 3, 4 is same is the motor 2 are same motor 1. The case 5 and 6 are the stop motor 3 action. If we case 0, the motor 1, 2, 3 are stop, and print the motors stop. The step motor 1, motor 2, let's set this motor. In the Visual Studio, like this, we can create new press bar, set the progress bar, and set the progress bar to the current form 1, 2, 3. This in the position in the board, and setting the enter and minus value of the progress bar. Meaning manual 0, max manual is 100, and value is 0. The 2, 3, 2 and 3 are same about the progress bar 1. Next, set the label to the current form. The label 1, 2, 3 is this in the board, and the interval of text of label is 0%. 1, 2, 3 are 0%, and label 1, the visible and enable of label 1, label 2, label 3 are true. The value is true, and the fore color is white, and the back color is green, and the new size is 18 and 13, and the font is Arial, and the size is 20. This These are the number 1, and the number 2 and the number 3 are same about with the number 1. And next set the timer 1, timer 2, timer 3 are new timer, and the timer interval is 500. And set the event handle for the timer 1 is new timer 1, timer 2, timer 3, and complement the new 0 point. The bound rate is 9600, and the date bits is 8. The motor speed. The priority is null, and stop peak 1. For this, we can create the common and the text. Okay, the 0 point get point name in the text box 1. If the Arduino not correct, we show the no COM port found. If the the COM is correct, it's sure in the text. For the front form 1 node, we set the bottle 1, 2, 3, 4, 5, 6. Total is 6 buttons. The enable is true. That's it. The enable is true. The 6 buttons is true, and action can work. For this, the button 1, 2, 3, 4, 5, and the 6 are same. I just introduce the button 1. The 2 and the 3, 4, 5, 6 are same. In the button 1, we compart 1, right line 1, right line from 1. The button 2 is right line from 2, and 3, 4, 5, 6 are same. The button animal is button 1 false, button 2 is true, and the timer starts, and the interval from the 500. If the progress bar value is 0, the percent will show in the progress bar. If the progress bar or the case 1, the motor not work, the message box show sorry, can't work. And for the button 2, the button 1 is clockwise, and the button 2 is counterclockwise. For the case, white length is from 2, and the button 1 arrow is true. The button 2 arrow is false. The different between the button 1 and the timer is stop. The button 1 is the timer is begin, and the timer stop. The progress value 0. The timer stop. The single or the numbers in the bottom in the progress bar is stop, not begin. If not work, we show the message back box also show the sorry can't work. 3, 4, 5, 6 are same. Is for the 3 and 4 for the Moto 2. The 5 and 6 is for the Moto 3. Are same about the same with the Moto 1. For the timer 1, timer 2, timer 3 are same. I just introduce the timer 1. The timer begin. The progress bar's value is 5. 5 it begin, and the neighbor takes sure the percent number, and the percent, for example, is 20%. Else the timer, if not work, else the timer stop. The button 1 and button 2, button 1 enable is true and button 2 is false. And if not work, arrow on printing number show the message box showed the percent in the percent in progress bar is not sure. The timer 2 and timer 3 are same, not trans. And for the read data from Arduino is 0 point the project function, and train the scale data from the Arduino. If true, we can set the or set on the Arduino into the Visual Studio. If not work, the message box show error reading data. For the box 1 is set this box 1, not just set the basic function. For the next, the connect, we can set the function. The text 1 just begin. The text 1 should please select a common part. If there have the com or the correct the success for the Arduino board, we can show they show the device connect and the value from the Arduino to the Visual Studio. Okay, next is it shows video of Control 3 RC serial motors on GUI use C++ and C#9 is working by Visual Studio. Next is the serial motor 1, motor 2, motor 3. We can set 1, 2, 3, 4, 5 from 0 to 19 and 180. If case the 6 from the 100 to 19 to 0. In the VS is Visual Studio. We can see the combox. Is informed. Connect the please select a COM port. Okay, the COM port COM4 and set the connect. There have error because the 0 point of Arduino not close is open. You can close and again. I connect again is set, show the device connected, and start 1. Press the start 1, just case 1 into the Arduino. Start 2 is case 3. Start 3 is in case 5. Stop 1 is case 2. Stop 2 is case 4. And stop 3 is in case 6. And show the percent in the progress bar. 1, 2, 3. 1, 2, 3. If the progress bar to the 100%, the motor is stopped. We don't collect the stop. We must connect the begin is start begin again. Next this is control 3 stable motor. In the Arduino, there is a stable 1, the stable 2, and the stable 6. Like this, it's counterclockwise. Counterclockwise, we can show this is clockwise. Now is counterclockwise of motors 2, and this for here, the motor 3 just clockwise, and in case 3, 6, okay, is working on the counterclockwise. And in the Visual Studio, it's next thing. The control step are same of the three serial motors. We can clock 4 collect, and start 1 is 1, this 2, this 3, this 4, 5, and this 6. We can see the state motor 1, motor 2, and motor 3 connect clockwise or counterclockwise. Now is the clockwise of the motor 2, and start 3 is the clockwise of motor 3. Start the 1 motor 1. Motor 1 is now is counterclockwise. Okay, this is my oral introduction of homework 2 sharp number 3 about control 3 stable and RC serial models by displaying on GUI at Visual Studio software use C++ and C# language. Thank you, sir.